Hello all, good evening. Welcome to the session. Today our topic is about Snowpark. Yes, what is this Snowpark? First, let us briefly talk about Snowflake. Snowflake, we all know, it is a data warehousing platform. It started as a data warehousing platform. And the main USP of Snowflake is that it can separate its storage as well as compute. Storage as a separate layer, compute as a separate layer. Due to this isolation, it can partner with other storage solutions like AWS S3, Azure's Blob, and Google's GCP. Over the period of time, this data warehousing software has evolved in providing data lakes and a regular query editor which is used to query the data warehousing has evolved in providing a compute platform that can build applications like ETL and machine learning. And now look into the Snowpark. Snowpark is developers framework created by Snowflake. It enables data engineers, data scientists, and developers to write code in their preferred programming languages. As of now, Python, Java, and Scala, these languages, you can directly write code in Snowflake's UI. If you want to use PySpark, Snowflake will not directly spin up those clusters for you. However, you can use the APIs of Snowpark in your local environment. It provides set of libraries, APIs, and allows you to build pipelines, ML models, and applications. In simpler terms, think of a Snowflake like a translator. Traditionally, Snowflake is all about data warehousing and a querying layer through which you can query the Snowflake. Now, the Snowpark is a translator which will translate Python, Java, Scala code into optimized SQL, which you can directly run on Snowflake's powerful server. Yes, why Snowflake has to do it? Because everything you cannot achieve in SQL. World is evolving and there is a lot of scope in ETL, applying machine learning, advanced ETL pipelines, data streams. All these tools came into the existence. Now there is a need for providing data transformation in multiple languages. So Snowflake introduced this Snowpark. This solution brings computation to data. Now instead of getting data to your environment from Snowflake's data warehouse, now you can take your code to the Snowpark, that is where your data resides in the Snowflake, nearer to the data warehouse. And it eliminates the need for separate ETL tools now. Within the Snowflake itself, you can create your ETL scripts and machine learning deployments. And it is developer friendly. It is a similar language, Python, PySpark, Scala, and the Java code. IDE, libraries, everything is managed by Snowflake. Some of the key features you can see here, multi-language support, as already we discussed, Python, Java, Scala, and how the data processing happens here. You have to read the data in your data warehouse into data frames. And Snowpark's data API supports this. And further, this Snowpark is giving you Spark-like lazy evaluation. Rather than executing the code at a time, only when you trigger some action, your code will be evaluated. This feature, Snowflake, saves a lot of computation because under the hood, it distributes the data. Just like Spark-like environment. Push down computing. Code executes where the data lives. So no more latency. ML and analytics. Native machine learning supports Snowpark libraries. So you can build and deploy models. Custom functions, you can create user-defined functions, and we have a rich library of Snowpark, which provides variety of functions and types, and enterprise security. Now you are not moving data here and there out of the Snowflake environment. Both your storage and compute is at one place. So enterprise level security. These are some Snowpark framework components. And I would like to discuss in this picture application layer. Let me start from the bottom layer. Let us say I have some like tables defined in data warehouse. That is my storage layer. Now I want to extract this data, transform or process this data. For that, Snowflake has created a compute layer which virtually distributes the data. Virtual compute layer. Okay, now we have storage layer, we have this compute layer. Now, before talking about these two, I would take you to application layer. Application layer is nothing but IDE in the Snowflake, or you install the Snowflake SDK APIs or Snowflake client libraries and write code in your local environment also. It's up to you. You can use IDE or using Snowflake libraries and APIs. You can also connect your local environment with Snowflake. And this application layer allows you to write Python, Java, Scala applications in variety of IDEs like Jupyter Notebook, scripts, IDEs, web apps. And further, the code which you write, basically it will be about transforming the data, processing the data, and this will be converted into data frames. Data frames is not a new concept. We have data frames in Pandas, PySpark. Now here Snowflake also uses this data frame API, which is called Snowpark API layer. Here the code which you write is executed, and the code which you write reads the data from the storage layer, and that code brings data into data frame API. Using the rich functions, you can perform transforms on that data frame. Further, you can write your user-defined function. If there are any iterative processes that you have to run on your data, you can store them as stored procedures. And all these high-level abstractions for data manipulation, this Snowflake API layer manages for you. This is similar to like Spark environment, but not exactly Spark environment, a Spark-like API layer. And under the hood, what happens? This Python, Scala, or PySpark or Java code which you write, which makes use of data frames, will be converted into equivalent SQL statements. And that SQL statements will be applied to your compute layer. And finally, that will be applied like you are trying to derive new columns, change the existing columns, filters, group by operations, whatever it is which you write in Java or Scala or Python or PySpark. If it is PySpark, then you have to bring in your local IDEs using Spark APIs, Snowpark APIs again. In your local, you can write your PySpark code. Java, Scala, Python directly in UI, UI's IDE, Snowflake's UI. You can write and run the code. When you run the code, already in your code, you will be making use of data frames, and your code will be executed, converted into equivalent SQL statements, and the virtual compute layer runs and applies them on your tables. So that is how here Snowpark APIs work. Some essential API components. To make use of Snowpark API, in the code, first you have to start the session. Snowflake.snowpark.session. That means it creates an environment. In that environment, all the APIs available. Once you initiate the session, then you will read the data. It could be a file format like CSV, JSON, or it could be table in the data warehouse of Snowflake. Snowflake manages both a data lake kind of storage and also data warehouse. Any one of this you bring into Snowpark data frame, which is similar like Pandas data frame. Snowpark data frame API. See, this is how you bring in that. Suppose I have a table called my table, session, which you have already initiated. Then I'll say session.table. I am reading data from table and the table name is my table. And all the contents in the table will be shifted to data frame in memory table. If you want to create it, data frame without reading from a table or a file, if you want to read from a file, you will mention the format and the path instead of table, and all the file content will be loaded into the data frame, which is in memory table. You can also create data frame. This is how you do that, session.create data frame. And you give like this. This is schema, ID, name, and you give each row like this, an array of values. With this, it will create a data frame. Okay, either you create a data frame or bring the file or a table into the data frame. Your objective is to transform it. To transform the data, there are variety of functions. You have to use this library, snowflake.snowpark.functions. If you want to figure out how to fill the missing values, check missing values, fill missing values, drop the duplicates, change the data types, invalid data types, derive new columns, whatever transformations you wish to do, those functions like aggregate functions, minimum, maximum, averages, and window functions, other functions you will find in this snowflake.snowpark.functions. From here, you have to import like this. From snowflake.snowpark.functions, import everything. Then you can use functions like column, year, sum. You will see this something relevant to Spark and Pandas. But when you import them, you have to use the libraries with a different name, snowpark.functions. And when you want to change the data types, or if you want to create a new column, you want to convert from one column, like a column's data type to other column data type. For example, date is defined as a string. You want to convert it into write date format. In such scenarios, you have to import types. See, you are importing everything from types. Then you can use integer type, string type. Especially rather than conversion, I would say this is if you want to define your own data frame as you wish with your own defined schema. Then you have to bring types, which are nothing but data types. Snowflake.snowpark.types. In this place, you will find all these data types. And the data frames in Snowpark. You create them from tables or data as we discussed. You transform, you import Snowpark functions, transform, and trigger the execution manually, single time, or you can create a schedule. On a schedule basis, you can trigger the execution. Results you can save back into Snowflake. Some data frame operations you can see. Select to select the columns, filter the rows, join, group by, order by. And if you see, these select, filter examples or transformations, and they are executed in lazy way. Only when you call actions like to show data, collect data, count data, write, then only your Snowpark go back and executes the transformation. This is like something like you know the homework, but only when you do it at the last moment when it is being asked, when it is asked to submit, you will quickly go and write the homework, something like that. Even though you apply filter function, join function, group by function immediately, that will not be executed. It will only design a plan how to execute. When you only ask for it, I am joining two data frames. Now I want to collect it. or I am asking to show it, or I want to write it as a CSV file or into a different table. These are actions. Then Snowpark triggers the transformations, just like PySpark environment. So this is how you get started. The things which we have discussed, you can see in code format now. First, you have to import functions. Before that, you have to start the session. After that, you have to import functions. See Python and session table. You are using this table and you are filtering it. See, this is like auto-generated in HTML page. Forget about these slashes. These slashes are not required. These are, you can ignore them. df.filter. And you're selecting the date and selecting other columns. And you group by product and aggregate. So that is one sample code for manipulating the data frames. And Snowflake provides Python worksheets. And these Python worksheets are browser-based development environments. And these are called as snow site environments. They will be available in user interface only. You can open it, write code and debug the code, debug and run the code there itself. And not only IDE, it provides pre-installed packages, auto sessions, and result viewer, built-in visualizations for data frame sorting and filtering. And all these worksheets are auto-saved and code runs on the Snowflake compute without any data movement. So advantage of this Python worksheets, suppose if you run code in local environment, you have to import the data from the data warehouse. Now that is not needed. Snowflake started as a data warehouse and it has a SQL editor. It also supports other SQL client applications to connect and query. And it also provides inbuilt SQL worksheets where you can write SQL code. Let us have a quick comparison between SQL worksheets and Python worksheets. SQL with Snowflake extensions, Python uses Snowpark APIs. And only Python 3.8 plus 9, 10, 11 and the latest versions can use this Snowpark APIs. And SQL is good for simple queries, reporting, and data manipulations like DDL or DML. But when you want to run complex logic, Python worksheets are better, like ETL pipelines, ML pipelines, any other procedural code. Here you can create limited variables, session variables. Here it's just like a Python. You can create as many you want. No native loops. Here you have full for while loop support. Here error handling, you can just use try cast. Here you can use try except blocks because it's Python. Libraries are not supported in SQL. In Python, it supports a lot of libraries like NumPy, Pandas, scikit-learn, which are into data transformation. When you want to run simple queries, SQL worksheets are better. When you want to run complex operations on your data, choose Python worksheets, which is your Snowpark environment. And here we have few examples. See, this is an SQL example. Select date and we are selecting a month. Date truncate function. From there we are selecting month. And we are summing up the amount from this table. And also we are counting. Counting as a transaction count. And you can see we are also applying a condition, that is date. And also sorting the data. And this is Python equivalent. From Snowflake, Snowpark.function, we are importing everything. And you give table like this, session.table. And then you're filtering sales data that is greater than this date. And you're creating a new column. Rather than creating a new column, you're like using the same name with dot with column, not creating. When you use the same name, whatever changes you apply to that column, like it actually creates a new column and replaces the old column. That's what it happens. And group by month, and we are doing some aggregations. And Snowflake also provides notebooks in Snowpark, like Jupyter-like notebook. You have markdown cells, visualization. You can connect to live data sources. All these collaborations you can make. Further, a more interactive space we have. SQL worksheets, Python worksheets are there. Further, a more interactive spaces, notebooks, just like Jupyter Notebook. That is about Snowpark, guys. Now let us look into small demo. For this demo, first I am setting up environment like databases, schema, table, everything. And once I do that, I'll run the Python code. For this simple operations, I'm using SQL, like creating database if not exist with wholesale DB as a name. Then I'm saying use this wholesale DB. And then use schema if not exist public. Public is the schema name, and that is also default schema name. Create schema and use schema. And also I'm creating a table. I'm using a CSV file. I know the attributes within that CSV file. With that attributes, I'm creating a table. This is some wholesale vendors data. It has channel, region, fresh, like fresh groceries, all the groceries details, fresh groceries like vegetables, fruits, milk, and other groceries, frozen groceries, detergents and paper. That is one type of groceries in the list. And delicacy number. I mean delicacy, we are calling it as a number. Now I'll create a stage, which is data lake. If I want to bring in files like CSV, I should create stage. I'm creating stage with name my stage. Now I created this stage. Rather than using this put file, I can go here, or I'll duplicate this. Yes, I'll click on this plus icon and click on add data, load files into stage, browse. I created this my stage just now. Select the data which you want to load and select the database. It's wholesale DB in my case. Select the stage, my stage. Just now I created it and upload the data. I have already done that, but I replaced the stage, right? So it won't be available now. It will be empty one. Again, I'll upload wholesale customers data 2.csv. You can see one file uploaded. Done. Now going back, I'll cross verify whether the data came into the stage or not. List at the rate my stage. You can see the file I uploaded. Now from this CSV file to the table I have created, I am loading the data. Copy into sales data, that is my table 9, and file is in my stage, and this is the file name, and file format is CSV, and other details, skip header one, because I already created the schema, so I'm saying skip header. Yes, loaded, and 440 rows are there. I'll select 10 rows from those 440 rows, that is from table, and you can see those 10 rows. Now we have set up the things. We have set up a database, schema, and then stage. We brought a CSV file. We copied that CSV file into the table. Now to do further transformations on this data, I'll use Snowpark. Just like your SQL worksheet, you see in SQL worksheet, when you create or replace, automatically these things will be selected. settings, especially the database and the schema. In Python also, that is in Snowpark environment also, first you have to select your database and the schema you are going to work in. I'll use this wholesale DB and public schema. And yes, that's what we have used here. Snow, uh, wholesale DB public, use public schema. Same schema I'm using here. And if you see in the settings, handler is main. You have to put all your logic in this function main. And return type table. For this function, return type is table. And packages, you can search for inbuilt packages. For example, pandas. It is there. NumPy. It's there. And by default, it's using 3.11 version of Python. That is your runtime details. Your runtime is using this, your environment namespace is using this warehouse and this schema. And packages, you have Anaconda packages and other stage packages also there. I just walk you through this code, and this, since kept under function, I cannot run few lines at a time. I can only call the entire function at a time. So let us look into the code. First, you have to import Snowflake Snowpark as Snowpark. And also here you have to select your data warehouse. That is also already selected. We are using default compute warehouse. And coming, first you have to import snowflake.snowpark. We are doing that. And from that Snowpark API, snowflake.snowpark functions. We already discussed that. From here, I am importing only two functions, column function, average function. And in the main class, first thing is I'm initiating session.sql. This is a function where you select your database, schema, everything. Even though you selected here, one more time we are saying use database. Use database wholesale DB, use schema public. And now session.table. Here I am giving my table name and saying df.show shows the first 5 rows. And then I am creating one more data frame df total. And from this data frame, I am using this dot with column function, which can create new column and also used to modify the existing columns. Here in total sales, this is a table now. This table is in data frame. On the data frame, I am creating a new column called total sales. And how I am filling the values in the new column, that is this total sales. I am summing up the values of fresh groceries, milk, everything, and I am saving as total sales under total sales. df total.show will only show you those details, total sales details. And further, I am using aggregation. I have imported average, right? Here I am grouping by channel. Channel is an attribute. We have channel 1, 2 like that. I am grouping by the channel and aggregating, summing up total sales. Actually, I should also import sum, but seems like sum is a default function. Even though you don't import, it's available. And summing up. And sorting channel wise and saying df aggregate show. And df total, we are writing it as a table like sales data transform. If that table is already there, it will be overwritten. Where in wholesale DB public, we are writing a table called sales data transform and return df aggregate. This one. Let us run this. All right, it shows the last output. And you can see the detailed output here. I have used df.show, 5 rows. This one. Then, after calculating total sales, again df.total show 5. You can see the total sales. And chat. Because it's having the total sales. If I take it to channel, not and no, because here we are summing up everything, we don't see those many points. You can also visualize the results. And aggregation also we are using this, but it is only showing the first two outputs. Go to output. Yeah, here it is. df aggregate.show, what it is showing? Channel and sum of sales, total sales. This one. And now the total, df total, this one. I am saving as table with the name sales data transformed. I'll go to this notebook and query the table, transform table. See this notebook also using same database, wholesale DB, same schema, public. And you can see those transform, which is having total sales column. Yes, that is how you can use Snowpark. Coming back, this is the notebook. Yes, that's how you use Snowpark. Thank you.